As urban landscapes continue to evolve under the pressures of climate change, urbanization, and burgeoning human populations, a curious and concerning phenomenon has emerged: the rising number of rats inhabiting cities around the globe. Recent research published in the journal Science sheds light on this unsettling trend, linking it directly to environmental shifts and human activity. The study underscores how climate warming has created more hospitable environments for rats, allowing their populations to thrive. Warmer temperatures have expanded the range of these rodents, enabling them to settle in areas previously inhospitable. Coupled with urbanization, which often disrupts natural ecosystems, and an increasing human population that provides abundant food sources, cities have become ideal habitats for rats. Researchers found that the complex interplay between climate factors and urban growth has contributed significantly to the increase in rat populations. As cities expand and climate conditions change, we are witnessing a shift in rodent behavior and distribution, said lead researcher Dr. Lydia Chen. These changes pose not only ecological challenges but also public health risks, as rats can carry diseases that affect humans. The impacts of this rat population surge extend beyond mere nuisance. They could have far-reaching implications for urban health and safety. Increased rodent populations are often associated with a rise in disease transmission, as rats can carry pathogens such as leptospirosis and hantavirus, which pose serious health risks to urban dwellers. Furthermore, the presence of rats may disrupt local ecosystems, outcompeting native species and altering food webs. In light of these findings, city planners and public health officials are urged to rethink urban management strategies. It's crucial to integrate ecological considerations into urban planning. Dr. Chen emphasized, we need to adopt comprehensive pest management strategies that address not just the symptoms of rodent infestations but also their root causes. As this issue gains more attention, it is likely that cities will begin to implement innovative solutions aimed at curbing rat populations while also mitigating the effects of climate change and urban sprawl. This could include enhancing green spaces, improving waste management systems, and utilizing technology to monitor and manage rodent populations effectively. In conclusion, the burgeoning rat populations in urban environments highlight the pressing need for a holistic approach to urban planning that considers ecological health alongside human needs. As cities grapple with the challenges posed by climate change, it is imperative that they remain vigilant and proactive in addressing the underlying factors contributing to rising rodent numbers. Future developments in urban ecology and pest management will be critical as cities strive to create healthier, more sustainable living environments in the face of these evolving challenges. In a recent Senate confirmation hearing, Robert F. Kennedy Jr., the nominee for Secretary of Health and Human Services under President Donald Trump, faced intense scrutiny over his controversial views on vaccines. Despite repeatedly requesting scientific evidence demonstrating their safety, Kennedy dismissed key findings presented to him, raising alarm among health experts concerned about his potential influence on public health policy. Throughout the two-day hearing, Kennedy maintained that he is not anti-vaccine, asserting his commitment to follow scientific guidance and overseeing the $1.7 trillion department tasked with significant health responsibilities, including vaccine research and approval. However, his responses concerning vaccine safety and efficacy diverged sharply from established scientific consensus. He continued to propagate the debunked notion that childhood vaccines are linked to autism and questioned the effectiveness of COVID-19 vaccines despite overwhelming evidence that these vaccines have saved millions of lives. During the hearing, Senator Bill Cassidy, a Louisiana Republican and physician, confronted Kennedy with definitive studies illustrating the safety of childhood vaccines. Instead of acknowledging this data, Kennedy countered with a flawed study which Cassidy himself admitted had issues. This exchange underscored a concerning trend of Kennedy cherry-picking research to support his claims while ignoring the broader body of scientific literature. Dr. Sean O'Leary from the American Academy of Pediatrics expressed deep concern, stating he ignores science. He cherry-picks sometimes fraudulent studies. O'Leary warned that Kennedy's stance could undermine public trust in vaccination programs. potentially leading to a resurgence of preventable diseases that disproportionately affect children. Moreover, Kennedy's comments regarding race and vaccination schedules further fueled criticism. When challenged by Senator Angela Alsobrooks about his past insinuations that black individuals may require different vaccination protocols, Kennedy cited outdated research suggesting a stronger immune response among African Americans. Experts swiftly refuted this, clarifying that vaccination recommendations are based on biological factors rather than race, stating, "There's no evidence that there needs to be a different vaccine schedule based on race." Senator Bernie Sanders also highlighted the implications of Kennedy's statements, emphasizing that as a nominee for a critical health position he should be well acquainted with the established safety monitoring systems for vaccines in the U.S. He reiterated that the scientific community has firmly established the life-saving impact of COVID-19 vaccinations, urging Kennedy to reconsider his position. As the confirmation process unfolds, many health experts are concerned that Kennedy's confirmation could lead to a further erosion of public confidence in vaccines. Dr. George Benjamin, executive director of the American Public Health Association, expressed that Kennedy's apparent lack of understanding of fundamental scientific principles required for the position raises serious questions about his qualifications. The implications of Kennedy's potential appointment extend beyond the immediate health landscape. As the nation grapples with ongoing public health challenges including vaccine hesitancy, the leadership at the Department of Health and Human Services will be crucial in shaping health policy and fostering public trust. Observers are now keenly watching how this situation will evolve, particularly in an era where misinformation about vaccines continues to pose a significant threat to public health. As discussions around Kennedy's confirmation intensify, it is clear that the outcome will have lasting effects on public health initiatives and the future of vaccination programs in the United States. The intersection of science and policy remains a focal point in the ongoing dialogue about health leadership and its pivotal role in safeguarding community health. In a groundbreaking era for cancer research, the exploration of cancer biomarkers has emerged as a pivotal element in the diagnosis, treatment, and monitoring of malignancies. Since the discovery of a urine protein marker for multiple myeloma by Henry Bence Jones in 1846, the field has expanded dramatically, with scientists cataloging thousands of biomarkers that span proteins, metabolites, DNA, and RNA. As researchers continue to refine their understanding of these biological indicators, the implications for cancer care are profound and wide-reaching. Cancer biomarkers serve as indicators of a cancerous process stemming from genetic mutations, epigenetic modifications, and other biological changes. These markers can be found in tumor tissues or bodily fluids, and the techniques used to analyze them have evolved significantly. As highlighted by experts, reliable detection methods are essential for improving patient outcomes, making the development of sensitive and specific tests a priority in ongoing research. Current methods for identifying biomarkers often involve tumor biopsies or less invasive liquid biopsies, which analyze blood, urine, or other fluids for cancer-related components. Among the key players in this landscape are proteins circulating tumor cells, CTCs, and cell-free DNA, cfDNA, each providing valuable insights into the presence and progression of cancer. For example, CTCs, which are shed from primary tumors into the bloodstream, have shown potential as prognostic markers, although their rarity poses challenges for widespread clinical use. Further advancements in technology have introduced innovative techniques for analyzing cancer biomarkers. High-throughput sequencing methods like next-generation sequencing (NGS) and polymerase chain reaction (PCR) are now commonplace, allowing researchers to detect a wide range of genetic alterations across multiple genes. These techniques enable a more comprehensive understanding of tumor genetics, paving the way for targeted therapies tailored to individual patients. In parallel with these developments, the search for effective cancer vaccines has gained momentum. A recent collaboration between the University of Oxford and pharmaceutical giant GSK aims to create a vaccine that targets precancerous cells. Professor Sarah Blagden, director of the partnership, noted that cancers can take years, sometimes decades, to develop, often remaining undetectable in their early stages. The goal of this vaccine is to intervene during the pre-cancer stage, preventing the disease from advancing to a more serious form. In another significant advancement, researchers at the Institute of Cancer Research have developed an algorithm to predict bowel cancer risk in patients with inflammatory bowel disease (IBD). By analyzing the genetic changes in precancerous cells, the algorithm can identify individuals at elevated risk for developing bowel cancer within 5 years with over 90% accuracy. This breakthrough could revolutionize how clinicians approach monitoring and treating patients with IBD, allowing for more personalized care and potentially sparing many patients from rigorous monitoring or invasive procedures. As cancer research continues to evolve, the integration of genomic sequencing and sophisticated algorithms into clinical practice stands to enhance early detection and improve treatment outcomes. The current trajectory of cancer biomarker research not only highlights the importance of understanding the molecular underpinnings of cancer but also emphasizes the potential for innovative solutions that could transform patient care. Looking ahead, the field of cancer research is poised for further breakthroughs driven by technological advancements and collaborative efforts between academia and industry. The ongoing exploration of cancer biomarkers, coupled with promising vaccine developments and predictive algorithms, holds the promise of a future where cancer can be detected earlier and treated more effectively, ultimately saving lives and improving the quality of care for patients around the globe. In a groundbreaking development that has sent ripples through the tech industry, Chinese artificial intelligence company DeepSeek has unveiled its latest models V3 and R1, which are being hailed as game-changers in the realm of AI. Released just 2 weeks ago, these models have achieved performance levels comparable to those of established giants like OpenAI's ChatGPT and Meta's Llama, but at a fraction of the cost and with significantly lower resource requirements. This revelation has not only sparked a flurry of interest but has also led to a staggering $1 trillion loss in market valuations among leading U.S. tech firms. The dramatic shift was catalyzed when DeepSeek published a technical paper on GitHub detailing the capabilities of its openweight R1 model. The company claimed that this model not only matches but in some instances surpasses the performance of its more well-known counterparts. Perhaps most striking is the revelation that DeepSeek managed to achieve these results without relying on the high-end NVIDIA H100 graphics chips, which are typically seen as essential for AI training. Instead, DeepSeek utilized less powerful NVIDIA H800 chips, suggesting a new paradigm in AI model development that prioritizes efficiency and cost-effectiveness over sheer size and power. The financial implications were immediate. Following the announcement, DeepSeek's app quickly soared to the top of Apple's App Store, while NVIDIA experienced the largest one-day market loss in U.S. history, shedding $589 billion in valuation. This reaction from the market underscores the anxiety among tech giants, with representatives from OpenAI even accusing DeepSeek of plagiarism regarding their models. Experts in AI are interpreting DeepSeek's emergence as a significant shift in the industry's approach to model development. The fact that DeepSeek could be built for less money, less computation, and less time, while being run on less expensive machines, argues that as everyone was racing towards bigger and bigger, we missed the opportunity to build smarter and smaller, said Christian Hammond, a professor at Northwestern University. This perspective challenges the long-held belief that larger models are inherently better, suggesting that efficiency can yield equally impressive if not superior results. At the heart of DeepSeek's models is an innovative mixture of experts approach, which divides the model into specialized submodels tailored for specific tasks or data types. This design allows for a dynamic allocation of resources, ensuring that only the necessary parts of the model are activated for any given task. For instance, even though the V3 model boasts an impressive 671 billion parameters, only 37 billion are utilized for processing a specific token, a term that refers to a unit of processing within large language models. Furthermore, DeepSeek has developed a mixed precision framework that optimizes training by allowing certain calculations to be performed using less precise 8-bit numbers, switching to more precise 32-bit calculations only when necessary. This change significantly accelerates training times while lowering computational costs. In a stark contrast to competitors whose training expenses can reach into the hundreds of millions, DeepSeek reportedly trained its V3 model in just 2 months for approximately $5.58 million. The implications of DeepSeek's advancements extend beyond just cost savings. Analysts predict that the rise of such efficient models could democratize access to AI technology, enabling smaller firms and researchers to compete more effectively. This shift could lead to a proliferation of new chipmakers entering the market, reducing the current dominance held by NVIDIA and similar entities. However, this democratization comes with its own set of challenges, particularly regarding the regulation and potential misuse of advanced AI technologies. As this dynamic landscape continues to evolve, the industry is left to ponder the future direction of AI development. While DeepSeek's success highlights the importance of efficiency and innovation, it simultaneously raises questions about the ethical implications and regulatory frameworks necessary to manage the rapid advancements in AI capabilities. The coming months will be crucial as the tech world watches how established players respond to this new competition and what it means for the future of artificial intelligence. In the quest for a sustainable future, nuclear fusion stands at the forefront as a tantalizing prospect for clean, virtually limitless energy. For decades, it has been touted as the holy grail of energy solutions, yet significant technical challenges have thwarted its practical implementation. However, a wave of innovation is emerging from both established institutions and ambitious startups, signaling a potential turning point in the field. Helion Energy, a Washington-based startup, is making headlines with its bold aim to achieve commercial nuclear fusion power by 2024. Unlike traditional nuclear fission reactors, which rely on the splitting of heavy atoms, Helion's approach focuses on combining lightweight atoms, a process that mimics the energy generation of the sun. This innovative method promises a smaller modular reactor design that lowers the risks of meltdowns and produces minimal long-lived radioactive waste. Helion has garnered over $500 million in private funding, reflecting investors' confidence in its technology and accelerating the development of its Polaris project, a prototype designed to harness electricity from fusion reactions sustainably. While some skeptics question the startup's ambitious timeline, the implications of its success could be transformative. If Helion or similar ventures succeed in achieving viable fusion energy, it could drastically reduce reliance on fossil fuels and lower global carbon emissions, making clean energy more accessible. Dr. N. White from MIT's Nuclear Science and Engineering Department notes, the global race for fusion energy is intensifying, with both government-backed projects and private enterprises making remarkable progress. In parallel, China's experimental advanced superconducting tokamak East, often referred to as the artificial sun, has recently achieved a significant milestone by maintaining high-temperature plasma confinement for 1,066 seconds. This achievement not only doubles its previous record but also marks a critical step towards creating a practical nuclear fusion source. Professor Song Yuntao from the Chinese Academy of Sciences emphasizes the importance of stable high-efficiency operation for continuous power generation, stating, "A fusion device must achieve stable operation at high efficiency for thousands of seconds." China's advancements in fusion technology are complemented by the ongoing efforts of the International Thermonuclear Experimental Reactor ITER project, which represents a massive international collaboration aimed at mastering nuclear fusion. Funded by 7 parties including the European Union, the United States and China, ITER is set to be the world's largest fusion reactor. With a goal to produce 10 times the thermal energy it consumes, ITER is expected to demonstrate the feasibility of fusion as a commercial energy source by the late 2030s. Despite the promise of nuclear fusion, challenges persist. Significant technical hurdles remain, such as maintaining plasma stability and achieving net energy gain, where more energy is produced than consumed. Furthermore, the high costs and long timelines associated with fusion research continue to fuel skepticism. Critics argue that investment might be better allocated toward existing renewable technologies like solar and wind. Nonetheless, the potential of nuclear fusion to revolutionize energy production cannot be overstated. It offers a virtually limitless fuel supply, produces no long-lived radioactive waste, and emits zero greenhouse gases during operation. Dr. Jane Smith, an environmental scientist, points out if we can harness fusion power at scale, it could revolutionize our approach to clean energy and significantly mitigate climate change. The integration of artificial intelligence and advanced computing technologies into fusion research is also paving the way for breakthroughs. AI is being utilized to predict and control plasma behavior, while high-performance computing allows for the analysis of vast data from experiments, enhancing research efficiency. As we look to the future, the path to commercial fusion energy appears filled with potential yet fraught with challenges. Achieving net energy gain, developing durable materials for reactors, and scaling up designs for practical use are critical steps that lie ahead. However, with sustained investment and international cooperation, the dream of nuclear fusion as a viable energy source may soon transition from the realm of science fiction into everyday reality. In conclusion, as startups like Helion Energy and initiatives like ITER and EAST continue to push the boundaries of what is possible, the global energy landscape could witness a seismic shift. The journey toward harnessing the power of nuclear fusion is still in its early stages, but the advancements being made today are igniting hopes for a cleaner, more sustainable future. In a groundbreaking development poised to reshape the landscape of quantum physics and materials science, researchers have unveiled the first conclusive evidence of a third form of magnetism termed ultramagnetism. This discovery, published in the journal Nature, promises not only to advance our understanding of magnetic materials but also to provide a crucial piece in the ongoing quest for efficient superconductors. Historically, magnetism has been classified into two primary categories: ferromagnetism, where magnetic moments align in the same direction, and antiferromagnetism, characterized by opposing magnetic moments that create a net zero magnetism. However, ultramagnetism introduces a compelling hybrid structure where neighboring magnetic moments point in opposing directions yet exhibit a twisted orientation, resulting in properties akin to both ferromagnetic and antiferromagnetic materials. This combination could allow for faster and more secure data storage, noted Oliver Amin, a postdoctoral researcher at the University of Nottingham and one of the study's authors. The implications of ultramagnetism extend far beyond theoretical interest. The newly identified class of materials may enhance the design of magnetic memory devices, potentially revolutionizing how data is stored and processed. With ultramagnets, researchers have the advantage of ferromagnetic properties which facilitate easy reading and writing of information, alongside the enhanced speed and resilience found in antiferromagnetic materials. Ultramagnets have the speed and resilience of antiferromagnets, but they also possess ferromagnets' crucial property of time reversal symmetry breaking, explained Alfred Daldin, a co-author of the study. This time reversal symmetry breaking allows for unique electrical phenomena to manifest, providing a deeper understanding of quantum behavior at the atomic level. The research team, led by Professor Peter Wadley, utilized photoemission electron microscopy to map the magnetic domains within manganese telluride, a material previously thought to be strictly antiferromagnetic. Their innovative use of polarized light revealed the intricate structure of these magnetic domains, paving the way for practical applications. With the successful fabrication of ultramagnetic devices, the researchers demonstrated the potential for creating exotic vortex textures, which are gaining traction in the field of spintronics, an area of study focused on harnessing electron spin for information transfer. This was a nice first example of how to create a practical device, Amin remarked, highlighting the significance of their findings. Moreover, the relevance of ultramagnetism is not limited to memory devices. It may also address a critical gap in the development of superconductors. Daldin emphasized this connection, stating, "Ultramagnetism will also help with the development of superconductivity. This class of magnetic material that has remained elusive up until now turns out to be this missing link in the puzzle." As scientists continue to explore the diverse applications of altermagnetism, the potential for breakthroughs in quantum computing, energy storage, and superconductivity appears promising. The discovery not only enriches the existing body of knowledge in material science but also sets the stage for future innovations that could redefine our technological capabilities. Looking ahead, the research community is poised to delve deeper into the characteristics and applications of altermagnets. With ongoing advancements in experimental techniques and theoretical understanding, the integration of altermagnetism into practical technologies may soon become a reality, potentially revolutionizing sectors reliant on high-speed and secure data storage. As researchers work towards unlocking the full potential of this new magnetic phase, the implications for both fundamental physics and applied technology remain vast and exciting.